Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homick's Middle School Earth Science Department. Today we're going to be talking about pressure, specifically high and low pressure. So before we actually get into that, you have to understand what pressure actually is. It's the amount of atmosphere pushing down on top of you. Now you necessarily don't feel it here, especially at sea level, which is about 1,013.0 millibars. But if you travel up in an airplane when your ears pop, either taking off or landing, that's a difference in pressure. Your ears are very, very sensitive to that. Your greatest pressure here at sea level, very simply because you have all the troposphere, the stratosphere, the mesosphere, and the thermosphere pushing down on top of your shoulders. The higher you go up through the atmosphere, the less pressure you're going to have. So the two different types of pressures we're going to talk about here at the surface is high and low pressure. So we measure this with what's called a barometer. And a barometer is actually going to have two scales, an inches scale and a millibar scale. The inches scale actually measures how much mercury is going to raise or lower within the barometer. And again, it doesn't matter what type of pressure you're dealing with, they're both going to be using the same types of scales. So here's a barometer that's going to measure how high or how low the mercury is going to be in the tube, and you have a little inches ruler behind it. It tells you inches of mercury. You also have this type of barometer here, which has a coil system that's sensitive to pressure, and the little dial will tell you what type of weather is going to be working its way in based upon pressure. This type of barometer actually has both scales, inches and millibars as well. So your high pressures tend to be dry weather, high and dry air, not a lot of moisture. So we generally associate high pressure with good weather. High pressure is generally good weather. You tend to get air that sinks because you tend to have cooler temperatures. Cool air contracts, causing the air to sink. And what happens here is you tend to have higher density air. Once that air hits the surface, it's going to diverge, it's going to spread out in all directions. From there, that air mass is going to have very little moisture in it because cold air doesn't have the capacity to hold a lot of moisture, so you tend to have very low moisture contents. These are anticyclonic systems, which means that the winds are going to blow outward and clockwise. So this is generally some very, very good weather in the area. So this is what a high pressure center might look like in the northern hemisphere, clockwise rotation and outward. Well, this is a view from up above. Clockwise and away from the center, the wind's going to blow. So you see it moved from west to east across because of our westerly wind belt. The jet stream caused it to move from west to east across the United States. And you see the outward clockwise rotation. This is a side view with the air mass sinking and then diverging at the surface. Very dry, very dense air, generally cool. Your low pressure is the exact opposite. This is lousy weather, really bad weather. This is very simply because air rises. Air rises because it's warmer temperatures. Warm air expands, has a much lower density, causing that warm air mass to rise up. Warm air generally holds more moisture, so you tend to have a high moisture content, lots of clouds, lots of condensation. These types of systems tend to be cyclonic in nature, which means winds blow inward and counterclockwise. These are going to be your hurricanes and your tornadoes and what we call your mid-latitude cyclones. There's your counterclockwise and inward rotation of your winds. West to east, the low pressure is going to move, and you'll see the inward and counterclockwise rotation with your winds. Okay, your winds are going to converge at the surface and causes the winds to rise upward. That warm air mass is going to cool to the dew point, and when it cools to dew point, you get cloud formations and lots of precipitation, and that's what's going to give you the lousy weather. This is a gorgeous picture of a cyclonic storm. You see the wrap-around nature of your clouds. You get the counterclockwise spin there. That's a great thing about low-pressure centers. You can really see the counterclockwise spin because of the cloud formation and the moisture content with it. So you'll see that pressure and temperature are going to have a very, very distinct relationship. High pressure, low temperature, low pressure, high temperature. That's going to be an indirect relationship between pressure and temperature. You definitely need to know it. So anytime you have a falling barometer, means you have low pressure coming in, means you have a storm system working its way into your location. So when you deal with falling barometers, it means that bad weather is on its way, so low pressure is coming in. So this is essentially what a weather map might look like from the Regents exam. High pressure, clockwise and outward. Low pressure, counterclockwise and inward. So that's it for now. Please make sure you understand the difference in high pressure and low pressure characteristics that is going to be essential in order for you to understand weather fronts. That's it for now. We'll talk to you soon.